The graph of a continuous probability distribution is a curve. Probability is represented by the area underneath the curve. In this case, outcomes are measured, not counted. We measure the area, and that's how we find the probability. The entire area under the curve is equal to 1. Probability is found for intervals of x, rather than for individual values. If we tried to ask about the probability of being at an individual value, it would look like this blue line. And if we wanted to calculate the area of a line, well, we can't. Lines, by definition, do not have area. So the probability of being exactly equal to a single value for a continuous random variable, that's equal to 0. If we wanted to find the probability between two values, we could calculate the area under the curve between the two values above the x-axis, and that would represent the probability of our variable being between those two values. Notice that because we don't have probabilities at exact variable values, it doesn't matter if we use the strict inequalities or the inclusive inequalities in this notation. The probability would come out exactly the same, because the only difference is whether or not we're including the area of a line, which is 0. The main difference between continuous and discrete random variables is that continuous probability is measured over intervals, while discrete probability was calculated at exact points. So instead of having a countable number of variable values, like we have with discrete distributions, a continuous distribution has unlimited variable values. Any two variable values you can imagine, there's another one that lives between them. So it's infinitely many variable values. Each of the intervals that we calculate probabilities over are continuous intervals. We're not looking at specific discrete points. Other than that, discrete distributions and continuous distributions do have many things in common. For example, the sum of all the probabilities was equal to 1 for a discrete distribution, and for a continuous distribution, the total area under the curve is 1. Also, for probabilities of a discrete distribution, all of the probabilities are greater than or equal to 0, and for a continuous distribution, all of our function values are greater than 0. All of our PDF curves will be above the x-axis.